Four major river project has changed hydrological environmental such as stream dredge, weir operation, and topographical change. Also global climate change and urbanization, which affect on hydrological characteristics, has changed hydrological environmental. So now, we need development of hydrological analysis methods with advanced technology for these changed environment. Division 3 consisted of 3 parts, which are rainfall, flood, and flood routing. In rainfall part, estimation methods of design rainfall method, temporal and spatial distribution methods are developed. In flood part, estimation methods of design flood by rainfall runoff model, frequency analysis, and conceptual rainfall runoff model are developed. Finally, integrated flood estimation software includes all research outcomes and interworks together. Development of estimation method for design rainfall is consisted of rainfall database, regional frequency analysis, and improvement of time distribution. All results comes with standardization progress and guidelines. Rainfall database is provided with qualified and corrected rainfall data for all stations. Regional frequency analysis is provided with guideline. Also, this research improved time distribution method based on Huff methods. This is well fitted to the extreme rainfall events. Main achievement of this research is the development of method for estimating ARF and spatial distribution of design rainfall. We calculate the aerial rainfall with radar rainfall that reflects the terrain and hydrometeorology. Also, we create storm-centered aerial reduction factor and ARF curve using the calculated results. For the final outcome, which is development of design rainfall determination, we collect the nationwide data of radar rainfall, then estimate the aerial rainfall and aerial reduction factor. Finally, we present the Korea aerial reduction factor and regression equation. A research defines parameters through verifications and calibrations that applicate rainfall outflow data of each basin area. Also will evaluate design floods of single and sub-watershed division in same basin. A research will suggest final outcomes about guideline for estimation of design floods using Korea's rainfall outflow data and will help improve reliability of design floods. The research consists of 2 main parts. The first one is on the development of channel routing technique for small and medium-scale rivers. In this study, a channel routing technique which considers channel characteristics is developed. Another one is about developing estimation method for design water levels in tidal river reach. In this study, a method considering variation of tidal water levels, flood discharge, and gate operation of weirs and estuary barrage is developed. The final objective of the research is to provide a guideline for channel routing and that for estimation of design water levels in tidal rivers. The objective of the study is to develop a methodology for design flood estimation by regional flood frequency analysis for ungauged catchments in South Korea. To meet the same, observed flood dataset has been gathered and assessed by hydrological models in correlation technique. The spatial extension method introduced is a newly suggested concept to generate flood dataset in watershed. The spatial data extension technique have been used to generate data using 2 models. One is storage function model, and the other is grid-based rainfall runoff model. Both observed and spatially extended data have been used to develop the characteristics of regional flood frequency. The characteristics of the regional flood frequency denote the homogeneity relationship between rainfall intensity and flood. So, flood frequency estimation procedures for ungauged catchments is suggested and used for estimation of design flood in South Korea. A Korean conceptual rainfall runoff is developed based on hydrological data of Gung River region. Further, the regionalization of rainfall runoff model parameter is developed for application at ungagged catchments. It aims to develop a Korean conceptual rainfall runoff model for flood estimation at gauged and ungagged catchments. A conceptual rainfall runoff model, GRR, represents hydrological processes of Kum River region. Regionalization of GRR model parameters, it allows to estimate model parameters with catchment characteristics for ungagged catchment, a manual of GRR for flood estimation. These final outcomes provide a foundation of future flood estimation method of Korean conceptual rainfall runoff model. We provide integrated system for watershed characteristics database and flood estimation software from South Korea. We design derivation of watershed characteristic database from South Korea and flood estimation software by using derived database. Finally, we provide GUI of integrated system based on GIS.